Potential divider is used to give outputs of 2 volt and 3 volt from a 5 volt source. As shown, what are the possible values for the resistance R1, R2, and R3?
Solve all your doubts on A-Level Insight Plus.
So, what does this mean is 5 volts has entered here. So that means if there is 3 volts at this point, 2 volts have been used up by R1. So R1 uses 2 volts. And if 3 volts enter here, but 2 volts come out of it, 1 volt has been used by R2, and the remaining 2 volts is being used by R3. So what does this mean is 2 volts of energy, potential difference of 2 volts. That means energy of 2 volts is required to move a charge. Energy of 2 joules is required to move one charge through R1, and similarly 1 volt through R2 and 2 volts again through R3. So from this we can clearly say something. We can say that R1 is equal to R3. Why? Because they are both taking the same amount of energy and they are in ratio with the same value. It is R2, right? So just see here, in which case is R1 equal to R3 and C, right? So our correct answer is C. Actually, there's another way you can see this, something like ratio, right? So it's R1 by R1 plus R2 plus R3 into EMF, also voltage by R1. So that means 4 over 4 plus 2 plus 4 into 5. So that's 4 over 4, 4, 8, 10 into 5, 2, that is 2 volts. Got it. So basically what we did here was we saw this. So what would happen if we kept a voltmeter at each of these resistors? They'd give voltage required to move charge through this resistor, right? So if 5 volts entering, 3 volts leaving, so 2 volts is the output, 3 volts entering, 2 volts leaving, 1 volt is the output, 2 volts entering, and there is no other component as 0 volt is leaving, it's 2 volts. So they both must be in the same ratio. Why? Because voltage is divided according to the ratios in a normal circuit. So R1 must be equal to R3. And if we look at something, we see here R1 is equal to R3. 4 and 4. The correct answer is C.